Okay, class, in this lesson, I'm going to show you how to write a linear function from a data table, as well as writing a linear function if a data table is not available to you. Okay, so let's start with the following data table. So we have the following x values, 0, 1, 2, 3, and their associated y values, so it would be -1, 4, 9, and 14. Okay, so I'm going to show you a three-step process to writing a linear function for this data table. The first step is to recognize the difference between these two numbers, okay? And to go from -1 to 4 means that it's a difference of 5. Okay, and then we want to take a look at the difference between these two numbers here. And to go from 4 to 9, we see that that is also a difference of 5. Okay, and then lastly, to go from 9 to 14, we see that that is also a difference of 5. So when we see that these differences are identical, meaning they're exactly the same, then we know that this is a linear function. So there's step 1. The next step is to take this difference, or in this case the number 5, and put that in the following equation. If you recall, this should look like the slope-intercept form for a linear equation, where last semester you learned that this was y is equal to mx plus b, and in this case we're just calling our y f of x. And we're setting that equal to mx plus b. So what you're going to do is you're going to take this 5, which is the difference in the y value that we just calculated earlier, and we're going to replace m with that number. So we will write the following. F of x is equal to 5x plus b. So that is step number 2. And there is step 2. Now, the last step is we are going to need to find the value of b. And how do we do that? Well, we will take one of the sets of data from the data table and replace f of x and x. So what we're going to do in this example is we're going to take this first set of data, okay, and we're going to take this x value, and we're going to replace x with that value, so this will be 0, and then we're going to take this -1 and replace f of x with -1. So it will look as follows. And now, finally, we will solve for b. To solve for b, we see that 5 times 0 is 0, and therefore we're left with this -1, which means b is equal to -1. And now that we know what b is, we can replace the b back into this equation, since this was the last piece that we were looking for. And so the linear equation for this table will be as follows. F of x is equal to 5x minus 1. Okay, so now you know how to write a linear function when given a data table. But what happens when there isn't one? Well, let's explore another example. So here we have a situation where a plumber charges $100 for a service call. That's just to come to the house to see what's going on. For each hour of work, the plumber charges an additional $150. So the question is, how much will the total service cost if the work takes 7 hours of work? Okay, so the first thing to do here is to create a data table based on the information that's provided. For our x value, we could say that it represents the number of hours of work, and then for the y value, we could say that it is the total cost. So let's go ahead and set that up. Okay, so let's say, for example, that if the work was only 1 hour, then the total cost will be the hourly charge, which is $150, plus the $100 service fee. So then the total cost for 1 hour will be $250. And then for 2 hours of work, we still have the hourly rate of $150, but we will not have another $100 service call fee. So then our total cost will be this $250 plus the $150, which becomes $400. And then for 3 hours of work, we would just tack on the hourly fee, which is another $150. And so that becomes $550. And then for 4 hours of work, we would do the same, tack on the hourly fee of $150, which would give us a total of $700. Okay, so then from the previous problem, we know that step number 1 is to find the difference. Okay, we already know what the difference is because of this hourly fee. Okay, so to go from here to here is $150, from here to here is $150, and from there to there is $150. So we're going to go ahead and write that in. $150. This is $150. And this is $150. Okay? Now, we did say before that if all of these are exactly the same, then this fits in a linear function. And so we're going to go ahead and write the linear function first and say that f of x is equal to mx plus b. Okay? And since we already know what the difference is, which is 150, we're going to go ahead and replace m with 150. So we're going to rewrite that and say f of x is equal to 150 x plus b. Okay? And then the last step is that we need to solve for b. Okay? And to do that, we can take any of these data sets and replace the x and the f of x. So we're going to go ahead and take the first set of points and replace the hours right here for x, and then the total cost, which is $250 for f of x. So that would look like this. 250 is equal to 150 times 1 hour plus b. Okay, and then if we were to solve for b, we'd see that b is equal to 100. And how do we know that? If we subtract 150 from both sides, we get 100 for b. Okay, and now that we know what b is, which is 100, we're going to enter that information back into this equation. Okay, so we're going to put that back in here and write the equation. F of x is now equal to 150x plus 100. Okay, so that is our formula for this word problem. And now we need to go back to the problem and answer the question, how much would it cost for 7 hours of work? Well, now that we know it's 7 hours, we can plug 7 hours in for x, and so it will be f of 7, which is 7 hours, is equal to 150 times, and rather write x, we're going to write the number 7 and complete the equation. Okay, so then f of 7 is equal to 150 times 7, which is 1050 plus 100. And adding 1050 to 100, we find that the total cost will be 1,150 for the entire job. Okay, so let's review. Step 1 is right here. Step 1, find the difference. Okay, step 2, which is right here. I'm going to call this step 2. Replace m with a difference. And then step 3, this is step 3. Replace f of x and x from one of the sets of data from the data table. Okay, hopefully that made sense. As usual, if that was confusing or if it wasn't 100% clear, please go back to the recording and listen to this again. Thank you.